So just to tidy up, I've got a couple of things, the neurogenesis to look at, synaptogenesis, and a few people's contributions, and then we'll do one or two little bits of practical before the end of the day. So common causes of all diseases is genetics, the environment. I talked about that before. It's a balance between what we're conceived with from our parents and what we do with our environment, which is more the epigenetic side of things. All diseases have the following things in common: oxidative stress, free radicals, inflammation and immune responses. So therefore we need to assess a person's genotype, in other words what they're conceived with, and their phenotype, which is what they've acquired. So everything therefore is a balance between the genetics and the epigenetics. So we have to keep bear in mind that you are 50% of mum and 50% of dad. You know, you're half mum and half dad, whether you like it or not. Dementia scientists identify vitamin deficiency that may cause decline. That, of course, is no big thing for us. It's vitamin D, which we've emphasized into the protocol today, to always remember about vitamin D for many, many different disorders. And to avoid blood clots, of course, would be vitamin K and K2. Sirtuins, so we've talked a lot about sirtuins, these proteins which can restore and regenerate tissue, and particularly the repair of the DNA itself. They're NAD, usually NAD dependent, and the NADP reverts back to nicotinamide, and nicotinamide is then recycled back to NAD through this salvage pathway, it's called, that needs those enzymes, and those enzymes are dependent upon the genetics, the inherited genes. So I'm going to whip through this because we've done all this. So when your cells experience stress, in other words, the environmental stress, acetyl groups are added to the proteins, and as a response to the change is induced by inflammation. The sirtuins remove these acetyl groups, so therefore keep the protein in service longer than usual, which is why these people live to great ages if they've got 100% expression of their sirtuins. So low levels of sirtuins are implicated in cancer, Alzheimer's, Parkinson's, Huntington's, amyotrophic lateral sclerosis, and motor neuron disease. We've done that little sheet there. We've talked about NAD. Don't forget DHA is one of the richest oils, and DHA may increase SIRT activity, particularly in the hippocampus, because Joe's alluded to the hippocampus and the limbic system, but we're going to get onto the hippocampus because this is the main area with cognitive decline and neurodegenerative problems. We've talked about sleep, and we've had a sleep in between the two seminars, the 2 days. Seems to have gone by very quickly. I keep thinking, oh well, I'll cover this tomorrow, and then I realize it is tomorrow, today. So we've sort of I'm just going through these. Sirtuins. Remember, all vitamin Bs get run down during prolonged periods of stress, especially the NADPH as it's involved in making cortisol. Sirtuins are activated by polyphenolic compounds. So I'm a plant, okay, and I'm in adverse weather conditions. It's freezing cold, it's too wet, too hot, too much ultraviolet there, and I'm being attacked by bugs, okay? So my defense is to build in a lot of polyphenolic compounds, in other words, extremely bitter compounds, to stop the bugs. And these polyphenolic bitter compounds then stimulate my sirtuin proteins, just in the same as in animals. Plants do the same thing. They have sirtuins 1 to 7, which are going to help repair the damage that's occurred. So it's a marriage between these two things. The NAD, or as we found, other coenzymes can stimulate the production of the sirtuin. But the increase of the amounts, it is dependent upon the polyphenols. So if I'm a tomato outdoors this summer, it was quite hot at times. In fact, we went away and everything dried out and died. So Not quite that extreme, as it was in early August and July. But those tomatoes had to fight to survive. Okay? They would have had potato blight, green fly, you name it on there. And if they managed at the end of the season to produce any tomatoes at all, it was probably a living miracle. But those tomatoes had something which the other tomatoes didn't. The tomatoes in the polytunnel just smiled all day, didn't have any natural sunshine because it was dissipated through the polythene, and they were sprayed regularly against pesticides. Eating that tomato doesn't offer you the health-giving properties because, 100, as I talked yesterday, I think 100 years ago, people wouldn't have eaten those vegetables. Okay? But because they haven't got these polyphenolics in them in the same way, they're now eaten by pests. So they have to use pesticides. So you can see how we've changed. And of course, in these rural communities, they don't use pesticides. They grow things in natural soil, which isn't full of fertilizers. So this brand new concept was talked about by Hippocrates 2,000 years ago. Okay, and I'm sure you all know, or 2,500 years ago now, let your food be your medicine. There's more than 8,000 different types of polyphenolic compounds, and they're divided into flavonoids, phenolic acids, etc. But we're mostly interested in 12, 13 of them, and a couple of combinations. So you see, this is a phenyl ring here. So a polyphenolic usually means it's got 2 or more phenyl rings in there. And those phenyl rings can act as antioxidants, and release resveratrol, quercetin, catechin, epicatechin, curcumin, rutin, fisetin, and apigen, and bryostatin, which I'm going to talk about. So you've got this sheet. I don't know whether you've got it. Have you got it as a separate sheet as well? If you haven't, yes, I think it's one of the. Is it one of the? No, it's not one of the appendix. If you want to print this out, or you want to print, I can put that on the internet on the website as an extra tomorrow. So you can see there's about 30 different polyphenolics there. I'm going to cover the most important ones that I find come up with people. So resveratrol, which was grape skins, peanut skins, a little bit in bilberries, raspberries, mulberries, but Japanese knotweed is the key commercial. Camphorol, interesting, the richest source of camphorol is capers. So we all know capers, that's what they put in tartar sauce, isn't it? So that was about the only good thing about the lunch fat, was actually in the rancid mayonnaise was capers, which is camphorol. But you'll see that there's a lot of other polyphenolics in capers. So a lot of polyphenolics are in single fruits and vegetables, and a lot of vegetables have different polyphenolics. So it's not as easy as saying, resveratrol, always grapes, because resveratrol is also in other plants as well. And grapes also have other polyphenolics. So eating our food is very good to have a mixture. Catechin, epicatechin, and epicatechin gallate is mainly what's in chocolate, and especially matcha green tea, pomegranate. Quercetin traditionally was in citrus fruits. Capers again, you see capers come up with quercetin, but our favourite is red onions. So red onions are particularly from Tropea. Yeah. They're the best. And then we've got oleoopin and hydroxytyrosol. This is extra virgin olive oil. Fisetin, I always remember, is strawberries. Curcumin, I think turmeric is the only source of it, but remember curcumin, or curcumin as Joe always calls it, curcumin is 2% of turmeric, so it's the concentrated extract. Let's see what else. Rutin. We find rutin comes up quite a lot. This is in citrus fruit skins. Buckwheat is the most common source of it. Rutin opens up the small blood vessels. Therapeutically, it's great for improving small blood vessel flow. In other words, that would be one that you'd suspect with vascular dementia. Berberin, that comes quite often up. That's in barberry, Oregon grape. I think those are the combination ones that we've been doing. Rosmarinic acid is in rosemary and oregano. people in Italy use this all the time. Almost every meal is rosemary and oregano, especially in the traditional areas where they live a long time. But you see, if you look at all these fruits and vegetables, they're all good. These are the things that you can see people say, well, it's so difficult. It's not difficult. You can buy these at any time, and you can incorporate 12 capers at lunchtime, whatever you have. You just put them onto salads, into eggs, or whatever you want to do. You know, these are all easy things, and of course, they've got to be organic, because we don't want a load of sprays coming in, load of pesticides, herbicides. So dietary polyphenols reduce blood pressure, they help asthma, cancer, infections, diabetes. So this just describes which polyphenolics activate each individual sirtuin. Then we found that sometimes the combination can work more synergistically than the individual one. And the first one we did back in September was EpiCert, which is a combination of walnut, grapes, pomegranate, and mulberries. So that was that one. We had difficulty getting mulberries, sufficient mulberries, and they're a bit dehydrated, but they're still gooey and sticky. So we substituted globe artichoke in there instead. So this included pomegranates, black walnut extract, grapeseed extract, and resveratrol. And then we found that this one was even better, was liposomal resveratrol, liposomal curcumin, quercetin, rutin, and fisetin. And that's the one you've been testing mostly and has tested up very well. Yeah. Possibly 80–90% of people, you know, if you were to say, well, which one would you suggest? If without testing, I would say PolyCert. But it does seem it works synergistically. I had somebody the other day who was fisetin, and they showed up to 4 capsules of fisetin. But when we took the fisetin away in the same test, they showed to 1 capsule of PolyCert. Did all the markers indeed. So they were very synergistic. And one very interesting one, which a lot of the research has been going into, I'd never heard is bryostatin. This is originally from a seaweed compound, but you have to have several tonnes of the seaweed to make a few grams out of it. So my quest, if it's in a seaweed, it must be in other things as well. So with a lot of research and a lot of searching, we found it was in quince. Now quince is about the most bitter thing you could possibly imagine eating. There's no pest will go through a quince. Crab apples are quite sweet in comparison to quince. So, and quince is lovely when you get it as a jelly, but it doesn't muscle test. It's been heated and it's been sugared, okay? But it still tastes nice with cheese and things. But, you know, if you get quince jam, it's great, but it probably does not contain any of the bryostatin polyphenolics. This one is been done from a pharmaceutical industry point of view. Everybody's looking for synthetics of this, so to try and make money and be able to patent it. So they're altering the polyphenolic compounds just a little bit and adding things on. And there's a lot of research coming out with this because it has been shown to stimulate synaptogenesis. And that's what it's all about with cognitive decline. This is the only one that they've actually found really, really does work, is the bryostatin. And I found that came up with somebody today. Somebody I tested and I said, oh good, bryostatin. Somebody's pointing over that way. Okay, so functional circuitry challenges. I did earlier on, demonstrated therapy localized CV21, a hypothalamus point, and then test each one individually, and then challenge them against the nutrients, and then find the polyphenol. And really it's as easy as that. The 2 things you've got to find is what is the cofactor to activate the chromosomal meridian. That's your first thing. You must find that chromosomal meridian. Once you found that, you found the answer to the person's problems. This is your life, okay? These chromosomal meridian assays are not the same as the traditional ones that we've used in the visible spectrum. These are in the ultraviolet spectrum. So once you start to use these, you say, yeah, you look at the back of your manual, look up the chromosome number, and then you'll see all the enzymes that are on that we can functionally challenge. So I just want to finish the sort of lecture part today with neurogenesis and synaptogenesis, and then I want to show a few practical parts, demonstrations. So where are the neurons that we've been talking about that are generated new in our brain, and what are the lifestyle changes we can make to allow and promote neurogenesis? Neurogenesis is the birth of new neurons in our brain. Generally, it was accepted that our brain had neurons that were finite in number. There are now many studies that show new neurons occur in humans as well as in rodents and other animals. One symptom to always bear in mind is depression. One cause, which may be that neurogenesis in our hippocampus is disrupted. Many times when this is restored, the depression lifts. Okay, so I'm sure you find this the same. So once you stimulated that brain, people who suffer with depression, it suddenly lifts, and it can lift extremely quickly. And interesting, many anti-anxiety and antidepressant drugs do the same thing. They work in this mechanism, but of course they're not actually solving the problem. So there's plenty of scientific literature there beyond the hippocampus and the areas there. So the brain has neuroplasticity. That's what Joe's been talking about all weekend. Means that it can change, and this is the important thing to remember. So it can mold and adapt by the production of new neurons. At the same time, there is, of course, death of old neurons. It's a balance. Most of us lose more neurons than we gain, and we don't want that because it means our brain is getting smaller. In pathological cases, of course, the loss is greater than the gain. So even if they're gaining new neurons, they're losing more at a greater rate, so the brain is shrinking. Anything that causes less stress or entertainment, novelty, uniqueness, happiness stimulates neurogenesis. That's why we hope this seminar this weekend has brought you happiness, joy, new learning, entertainment. Any stressful events are negatively impactful to neurogenesis. So anything which is negative reduces neurogenesis. The main parts where this all occurs is this area in the limbic system called the hippocampus. Hippocampus, as Joe's been going through, is very much in the temporal lobes. It's embedded deep in there. It's responsible for learning and memory. It's plastic and vulnerable structure. It's impacted by chemotherapy very much. It organizes emotional responses. It involves recollection of past experiencing and imagining the future. You see, Axel knew what he had to eat last night or the day before. Full English breakfast. Okay? So that was the memory. What was he going to buy his wife on her next birthday? Everybody remember? Flowers. Flowers, you see, yes, you see. So he was imagining or just reproducing what he'd done before. No, you're shaking your head. You're not going to buy roses.
No, that's for our anniversary.
That's for the anniversary. Okay. What do you buy her for her birthday? Nothing. Okay. So it's involved with spatial navigation. So spatial navigation, I also don't have to go into, depends upon where people are and their position in space. It's pattern recognition. So it's recognizing things, old patterns and old habits, and visual recognition. It's the regulation of the hippocampus. So it's a hypothalamus. So it regulates the hypothalamus, and vice versa. As we'll see, the hypothalamus regulates the hippocampus. High cortisol in patients, it destroys the hippocampus. So when the hippocampus becomes atrophied from high cortisol, so this is prolonged stress. Now on this side, 700 new neurons daily. So the whole of the hippocampus is replaced in 50 years. Okay. May have to wait a long time. And this is why certain memories which are laid down in there, we can't remember anymore because they've actually been destroyed. And every time you learn something new, you lay a new neuron down and make a new synapse. So every time you hear Axel about what he has to eat, and you're excellent at remembering, and what he's going to or what he's not going to do, okay? Every one of those is a neuron. So it's fantastic what you've learned and what you've probably laid down as new neurons. And that, remember, is only in the hippocampus. This is going on in all the brain, in every lobe and things. It has neurogenesis, but the studies were on the hippocampus. So reduced new cells causes depression. So if you don't make the new cells, you can't take on board the new information that you're learning. So no wonder if you'd missed the seminar, or you didn't understand the seminar, you'll get depression. So you need to watch it again and again and again, and then you'll develop those and your depression will lift. So earliest and most severest affected structure in neuropsychiatric illnesses, so that's not just cognitive decline, but all these other ones like depression, epilepsy, Alzheimer's, Parkinson's, stroke, etc., all abnormally affect neurogenesis in the hippocampus. The limbic system is there to protect us and for survival. The hippocampus is in turn connected to the other regions of the brain. I think you've adequately shown that this weekend, Joe, because if you notice the first thing that Joe went to, and then another one came, and then another one, those interconnections, really any lobe can be talking to the other parts. So we mustn't think and say, oh, the cerebellum is just that, and it doesn't make connections to anywhere else. Everything has connections in there. Main function is encoding for memory. Lack of hippocampus functioning will lead to cognitive decline. The role of chemotherapy is to reduce new cell production. Obviously, that's the therapy with it. One reason for depression is with the chemotherapy, because we're not stimulating neurogenesis. Neurogenesis does not get back on track when chemo is discontinued. It takes time. So when people finish their chemo, they still remain very low and depressed. It takes many, many weeks to get over it. New neurons are essential to process new events and to store them and organize them. Okay. That's how we learn. We learned when we first came here in September, we learned the hard way that how not to get here. We followed the sat-nav, and the sat-nav took us to a field somewhere in the middle of nowhere and said, you're here, you're at your destination. And we said, oh, really? So it was time to switch her off then, because every time you move forward, she was saying, take a U-turn and all that sort of thing. So when we went out that evening by taxi, he took us through the town. So now we've learned, we come in off the motorway into the town and up that way, rather than trying to find the other side of the motorway over this side. Okay? So we learn, and that's spatial awareness, isn't it? Because we know we go down to the Sandeman Hotel and turn left, and after once or two journeys, you know where to turn left and where to right, and you don't need the sat-nav. We've learned. So we laid a lot of neurons down between that. So new neurons are essential to process new events and to store them and organize them. So this is the great thing. Next time we come, we'll probably go straight through. We'll know exactly where to go. So neuronal stem cells, these are the cells that manufacture or synthesize or make new neurons. Glutaminergic, that means that they're sensitive to glutamic acid or glutamate. Neurons trigger and enable the production of new stem cells. So the production of new neurons is dependent upon glutamic acid or glutamate. So we tend to think about glutamate being an excitatory neurotransmitter, which it is, but it also has other roles in the hippocampus, and it's actually firing it up to make new cells. The hypothalamic supramammary process, the nucleus, the SAUM, is where this information goes. It can regulate hippocampal neuronal stem cells. So here we see the hypothalamus, which is the great regulator of all the hormones and body tables, temperatures, etc., telling the hippocampus to produce new cells. So as the neuroblasts mature, that's the new cells that have been stimulated by glutamate. As the neuroblasts mature, GABA inhibits inputs from the supramammary nucleus and helps regulate the dendritic development. GABAergic inputs then are important for integration into the structure of the hippocampus. So now we come across two very, very important neurotransmitters, glutamic acid and GABA. Okay? The glutamic acid is an excitatory, and GABA is actually an inhibitory neurotransmitter. Okay? So this is interesting. You've got excitation and you've got inhibition. But both are neurotransmitters, which are the glutamic acid is because it's going to be high, will be circulation sex, and if it's low, it'll be triple warmer. So triple warmer operates, or the glutamic acid excitatory neurotransmitters operate all the 5 senses. So we want the maximum input in the fastest space of time, and all the eyes, the ears, the hearing are all glutamic acid. GABA, if it's low, can't integrate the cells, the new cells. So what we find is that GABA is an inhibitory neurotransmitter, and when it's low, it's on the large intestine. When it's high, it's the lung. Okay? So large intestine, now that's the area where we get the butyrate made. Okay? So if you've got large intestine as your problem, as your major hormone, meridian, what's the word? Get towards the end of the day. Your meridian indicates immediately you've got low GABA. And if you get low GABA, you're going to produce less and integrate less new stem cells into your neuronal structure. Does that make sense? Okay, good. So now we see why people who are large intestine have problems from many directions. They don't produce the butyrate, but they also, large intestine indicates low GABA, which means you're not going to get the new cells integrated. So large intestine people are people who have got real problems with their brains. Okay, and ultimately will probably get more problems with their brains than other people. Okay. So neuronal stem cells make new neurons from bone marrow. Although, as I told you yesterday, the occipital protuberance, which includes the internal and the external occipital protuberance, is the only source of bone marrow cells in the skull. So this is why it's very, very important and why they're there. Why are bone marrow cells in there? Apart from to produce probably new blood cells, but they can in turn go on to make any new cells, including neurons. So the main source probably of new neurons in the head, in the cranium, is probably from the external or from the occipital protuberance. The brain has also some stem cells called neuronal stem cells in the dentate nucleus, which is where the hippocampus is buried. The hippocampus activates the neuronal stem cells. Okay, how to trigger neuronal stem cells? There are 2 signals, the glutamanergic and the GABAergic. In the hypothalamus, there's a structure called the hypothalamic supramammary nucleus. Under the influence of glutamanergic signal triggers, the hippocampus stem cells start to proliferate to make new neurons by copying itself. So glutamic acid is an acid which we can make ourselves. It's a non-essential amino acid, and we can get it from certain foods. GABA, we don't eat GABA, we have to make it gamma-aminobutyric acid, but interestingly it's made from glutamic acid, converts to GABA, and to do that it needs vitamin B6 or pyridoxal 5-phosphate. So you'll see the most neurochemistry, pyridoxal 5-phosphate is really, really important. So here we see it, the glutamate activating. So if it's high or low, if it's high, it's on circulation sex is over, and triple warmer is under of the glutamate. The mammillary nucleus then self-renews, so it's telling the cell here, the neuron, make another copy of yourself, make another copy of yourself, like a reproduction. And this then proliferates thanks to glutamate and makes cell after cell after cell, which then differentiates from stem cells into neurons. So now we're making a little baby neuron, and that's the differentiation which needs the GABA. So if we've got a large intestine problem or possibly even a lung problem, we're not going to differentiate. The dendritic development then occurs when we make all the feelers that come out to make contact with the other cells, and the final path is the integration, which again needs GABA to join the new boy in with the old ones. So that's the integration part. So the supramammary nucleus then produces GABA to differentiate stem cells to forming new neurons. Then under further development influence, GABA signals start to develop. Vitamin B12 is necessary for cell division, so deficiency can interfere with the whole process. We've already met quite a few people who showed a methylcobalamin or adenosylcobalamin, here already. Also lack of folate, and of course lack of amino acids like glutamate, glutamic acid, which are necessary to make DNA. How do we accomplish them? It's the neurons that have to bring the signals to the right place, such as enriching the environment with uniqueness. The more withdrawn we are, the less neurogenesis occurs. That's, I think, becoming obvious now, isn't it? The more of a loner you are, the more you become a loner. Enriching the environment by having a candle. How many of us light a candle? You do. Yes, good. And lighting a candle gives you a very different environment. Go out, but vary the routes when running or walking. I tried this, and I found the other routes that I started doing. I thought, I'm going to do this every day when I run. And I found I was more tired because I realized there were more hills and things on the other routes than the one I normally do. So I like the one I normally do, the routine, because I know exactly how long it takes me, 20 minutes. I know when I do the hard bit at the end. Even doing it round the other way fools me completely. Yeah. But it was just like, as I said in Waitrose, when they moved all the shop round, we had to search to find where the olive oil was, or where the oil was, or the bits. But that's good, I realise now, for the brain. So variation, learning something new, is very, very important. Look at new things. Try a new fragrance. Fastest way up to the limbic system and the hippocampus is up the nose with the smell. You know, if you smell Brute aftershave, you can immediately remember the last man you ever came across who used that. In the same that we sometimes have women's perfumes, and we think, so a woman goes past with the perfume, and you throw back 40 years, and you remember the person exactly. The impression the fragrance makes is enormous. You know, we think, oh, only animals really can differentiate. We smell up the nose, swoom, straight into the amygdala and the hippocampus, much, much more than what we give credit to. Okay, try new tastes. Go Chinese sometimes. Go Indian. Go Thai. Try new tastes, new experiences, new herbs, new spices, new flavors. New textures. Don't always have the same bland food. Have things which make you chew much more. Have just different textures to your foods. Art, and particularly art. Very important for the imagination. So, you know, just a few examples of art. We've put fragrance, we've put candles, looking at art, having ghee, of course, and as we'll see in a minute, running. So there's robust scientific data on adult neurogenesis occurring. Neurogenesis, and this is what I said yesterday, and again we talked about that this morning, I think Joe did as well. Neurogenesis is greater, obviously growing the brain is in the womb, but after that period the greatest development of neurogenesis is in adolescence. In other words, age about 13, 15, 16, but decreased in an inflammatory state. So chronic inflammation will decrease it. Injuries, possibly because we don't get out so much. Long COVID, okay? So this is very reason why long COVID leads towards cognitive decline. It can result in depression that can last forever, okay? So remember this is when these kids, and this is what we're storing up, a lot of these kids who couldn't be with their friends, who couldn't play sport, couldn't have new experiences for nearly a 2-year period. What's going to be happening to them as time goes on? They can never restore that, okay? They can never go back and say, oh, I'm going to catch up with 2 years worth of growth of my new neurons. So that depression can lead then to a lot of isolation and a lot of mental health, which we're hearing about now very much, isn't it? The happier they are, the better their brain function for the rest of their lives. The happier they are. So if you've got children who don't see themselves as being happy, or obviously are in a bad environment, bad socially, and are very unhappy, they become unhappy, depressed adults. Does that make sense? You can see that, can't you? With the importance of with bringing up children, they need a happy environment. They don't need a stressful environment, and in that environment, they need lots of activity, and that's why sports are good. Even they say they've discovered that maybe gaming, you know, the computer games and things, at least it gives them some form of stimulation. Running increases cell proliferation and neurogenesis much more than walking. Running, okay? My kids used to laugh at me because when I go out for a run, I put Jeff Bland's functional medicine update on my telephone, and they say, "Oh, what music are you listening to, Dad?" I said, No, I'm listening to biochemistry updates." And then they put them on and said, "Why are you doing that?" I said, "Because that's how I learn." And then he said, "Why do you learn that?" Because neuromuscular contraction involves acetylcholine, and acetylcholine is what helps you restore your memory. Your memories are acetylcholine. And I put that down as the sole reason. Now I know every time I listen to Jeff Bland, any bit of new information is actually laying down a new synapse, and it's a new nerve. So running increases cell proliferation. So if you run and learn, then you don't have to take the new route. You can do the old route, but listen to a new monthly update from Jeff Bland. Reading creates images. This is important again as we get older. You can read and you can read. You can read and get to the bottom of the page and think, I don't know what I've read. It hasn't done anything. But you can read and create images from what you've read. And I often do that. I read a line or two and then my mind's gone off here and I'm imagining that and I'm thinking, how can I integrate that into the teaching? Okay. So, but reading, if you read perhaps a novel, somebody will say, well, unless you stop to read and think about the situation with that, you can read it and then it doesn't actually go in very much at all, so it doesn't lay down new neurons, but creates images and events in the mind. So I would suggest everybody uses Harper's Biochemistry for this. If you have difficulty sleeping, it's a wonderful sleeping book. So to stimulate neurogenesis, running, reading, novelty, something which is fun to remember. We need our sleep because of our circadian rhythm. Sex. I thought that might interest you.
That I woke up now.
You've just laid another neuron down.
Yeah, certainly.
Okay, you had no idea that sex was good for neurogenesis. Learning, intermittent fasting. That's the bit where you can only eat for sort of 8 hours of a day or whatever, or calorie restriction. 20 to 30% reduction of calories stimulates neurogenesis. Blueberries, but I would put blueberries, I wouldn't put blueberries, I'd put bilberries in there. Fisetting compounds, blueberries are just largely a waste of time. Blueberries are cultivated bilberries, and bilberries are much, much different. Flavonoids, some are keen on dark chocolate. We found with muscle testing, we had to muscle test lots of bars of chocolate. Jill was the main control here, okay. And in fact, there was only one which really works as far as the polyphenolics, and that's lint, 85%, okay. And the reason is that apparently chocolate is alkalized in the process of making it. If you look up the alkalization, it actually destroys the polyphenolic compounds. So even if you have a 90% organic, it does not do the sirtuin stimulation. It has to be 85% lint. In other words, it has to be non-alkalized chocolate, okay? And then that muscle tests very well to stimulate sirtuin.
Dutch chocolate.
Dutch,
De-alkalized.
yes,
Dutch
yeah,
chocolate.
Dutch
Don't
chocolate.
buy that.
Yeah, okay. So dark chocolate in that way. Curcumin, it's suggested curcumin, that extract from turkey, must be in oil. The only way you can get to absorb is in oil, but it's better, the best way to do it is to get the liposomal one, which is what we do. It's a capsule, it's not a liquid, and so you can just swallow it. So it's already encapsulated in phosphatidylcholine. Caffeine is a very good source, or coffee and tea. Resveratrol, and particularly resveratrol in oil, and again that's one of the reasons we've gone to the liposomal resveratrol, because it gets absorbed much better. Omega-3, because our brain is made of omega-3, particularly the DHA. B12 and folate, because that's important for DNA. Zinc for tissue repair. Vitamin A, because this is the major gene expression. So most of our gene expression of our cells is regulated, gene regulation by vitamin A or retinol. High sulfur diets which increase glutathione, that would be certain vegetables like cabbage and cruciferous vegetables. Crunchy food, not crunchy bars, crunchy food. So anything where you've got to crunch and things is stimulatory. Chewing gum will do this. Not that I'm a great, but apparently chewing gum you're working on. Fragrant food, nice smells to it like Thai food. And any event that increases blood flow. You'd agree on that one. Any event that increases blood. So negative neurogenesis. This is the fella already here. Stress. So any periods of prolonged stress are going to be negative to neurogenesis. You know, whenever I've had stress in my life, I can't think. It just stops you from thinking and making sensible decisions. You want to make a decision, but you can't do it, and it's very, very difficult. So stress has a profound effect on neurogenesis. Aging. I was reading an interview with Derek Jacobi. Do you know Derek Jacobi, the actor? Yes. And he's about 84 now. And the interviewer said, "How were you coping with old age?" And he said, "I don't let the old man in." Which is very good if you think about it. You can only accept old age if you think. People say, "Oh, I hate getting old." And I thought, you're becoming old by the mere fact that you're saying, "I hate getting old." Because they can't hear so well or can't see so well, or they're hobbling around a bit. You know, they're becoming old people. You mustn't ever allow the old man in. Chemotherapy, inflammation. Obviously anything is, it has chronic low-grade inflammation, and you know, you've learnt this weekend, the major source of chronic low-grade inflammation is the bowel. High saturated chemotherapy, obviously, we talked about high saturated fatty diet, definitely increases the immune response. It increases the immune reaction. High sugar diet, but not necessarily fructose from fruit. Low vitamin A, and I would put probably low vitamin D in there as well. Low B12, low folate. Alcohol in excess, and a soft diet, so there's no crunchiness and taste and fragrance. So a soft, bland, takeaway type of food is not good stimulation for the neurons.